warmly welcome to Adarsh Educational Institution. It's my pleasure welcome you all to the online class. So in the last class we discussed the solved problems in Unit 5. So today we see the numerical problems, that means the book bag problems. So first question, that means the answer very briefly questions. Question number 4. What will be the frequency of sound having 0.2 meter as its the wavelength? They given a wavelength, and when it travel with the speed of that means the speed of velocity of sound, they can be 331 meter per seconds. So the given value, input values, they given the value v is equal to 331 meter per seconds, and then they given the lambda, that means the wavelength. Lambda is equal to 0.2 meter. So we find the frequency, that means the n. So we have the formulas, that means v is equal to n lambda. So we know the v and then lambda, so we find the n. So that's why we move from m in the left side. So n is equal to v by lambda. So we substitute the values in this equation, in these formulas. So n is equal to 331 divided by 0.2 meter. So it gives n is equal to 1655 hertz. And then answer briefly question number 3. Air temperature in the Rajasthan desert can reach 46 degrees Celsius. What is the velocity of sound in air at that temperature? We give the V0 value. V0 is equal to 331 meter per seconds. So they given the value of velocity of 0 degrees Celsius. That means 0 degrees Celsius V0 is equal to 331 meter per seconds, and then temperature, they given the temperature. So what is that? T is equal to 46 degree Celsius. So we know the effect of temperature values. So Vt is equal to V0 plus 0.61 temperatures. So we know the value of velocity of object, that V0 is equal to 331 and 0.61 into temperature. Temperature, that means 46 degree Celsius. We multiple the 0.61 into 46, the value is 28.06. 28.06. So we add the two values of 331 plus 28.06, it gives a Vt is equal to 359.06 meter per seconds. And the next one is a problem corner. Question number 1. A sound wave has a frequency of 200 Hz and a speed of 400 meter per second in a medium. Find the wavelength of the sound wave. So to find the lambda, that means the wavelength, so we given the velocity of 400 meters per second, and then frequency n is equal to 200 hertz. So already we know the formulas. V is equal to n lambda. So we find the lambda, so that's why we move from left side. So V is equal to V divided by n. So lambda is equal to V divided by n. We know the value of V and n. We substitute the value in this formulas. So lambda is equal to 400 divided by 200. So we substitute, we cancel the both zeros are there. So this 0, this and this one, and 1 2s are 2, 2 2s are 4. So lambda is equal to 2 meter. Lambda is equal to 2 meter. And then second question. A thunder of cloud is here 9.8 seconds later than the flash of lightning. If the speed of sound in air 330 meter per second, so what will be the height of the cloud? So what will be the height of the cloud? So that means, so to find the distance of the clouds. So given a time is also given. T is equal to 9.8 and then velocity is equal to 330 meter per seconds. So the given value is equal to V is equal to 330 meter per seconds and the T is equal to 9.8 seconds. So if you find the distance, of the clouds, that means the height of the clouds. So D is equal to, we find the D. So the formula is V is equal to D by T. Velocity is equal to D divided by T. So D, we find the D, so that's why D is equal to V into T, velocity into T, time. So D is equal to 330 into 9.8. So we multiple these values, it gives D is equal to 3234 meter. So the value is D is equal to 3234 meters. And then question number 3. A person who is sitting at a distance of 400 meter from a source of sound. So a person who is sitting at a distance of 400 meter from a source of sound is listening to a sound of 600 hertz. So to find the time period between two successive compression of the source, successive compression of the source. So to find out the time period. So if you find the time period between successive compression from the source, so they given the value of hertz, that means a frequency, that means a time. If you know that, if you find the t time period, if you find the t, so they given the value of hertz also. So hertz, that means a frequency n. So n is equal to 600 hertz, and then we find the time period t. So we know the formulas of frequency is equal to 1 by t. Frequency is equal to 1 by t, that means n is equal to 1 by t. So if we find the temperature time, so that's why time is equal to 1 divided by n. Time is equal to t is equal to 1 by n. So t is equal to 1 by 600. T is equal to 1 by 600. So 1 divided by 600 is equal to, its value is 0.0166. So if you find the value, if you round off the value of, so t is equal to 0.0017 seconds. So the time period between the successive compression is 0.0017 seconds. And then an ultrasonic wave is sent from a ship towards the bottom of the sea. It is found that the time interval between the transmission and reception of the wave is 1.6 seconds. What is the depth of the sea if the velocity of sound in the seawater is 1400 meter per second? So if you find the depth of the sea, they given the value. So when ultrasonic wave, that means when a wave is transmitted to the depth of the sea. So if you transmit the wave and then to reach the depth and then to reflect and to reach the reception, that means a receiver. So it is if a total time. So if you transmit the wave to the depth and then to reflect the receiver, so if we take the time of 1.6 seconds, so t is equal to 1.6 seconds. And the next one is a velocity, v is equal to 1400 meter per seconds. So t is equal to 1.6, and d, we find the d. So we know the formula of v is equal to 2d by t, because of this one is the two distance are there. So one is the transmission. So if we travel the depth and then to reflect the depth to the ship, so two distance. So if we find the value of d, so v is equal to 2d by t. So we find the d. So that's why 2d is equal to v into t. 2d is equal to v into t. So we substitute the values in these formulas. So 2d is equal to, the velocity is 1400 into time 1.6 seconds. If you multiple with the two values, that means 1400 into 1.6, the value is 2d is equal to 2240. That means 2d is equal to 2240. So if you find the d, so that's why d is equal to 2240 divided by 2. So if we cancel these values, so one is the one time 1 to 1 is to 2, and then 1 1, and then 2 0. So if the value is 1 1 2 0, so the d is equal to 1120 meter, 1120 meter. And the next ones, a man is standing between two vertical walls at 680 meter apart. He claps his hands and to hear two distinct echo after 0.9 seconds and then 1.1 seconds respectively. So what is the speed of sound in air? So if we clap the hands, two distinct echoes. So one is the 0.9 and then another one is a 1.1. So if the distance is equal to 680 meter, 680 meter. So if the given value is distance between the two vertical walls, that means a d is equal to 680 meter, and then time taken first echo is equal to 0.9 seconds, and the time taken for second echoes t2 is equal to 1.1 seconds. So if we find the velocity of speed of sound, that means speed of sound, that means v. So if you solve the formula, speed of sound is equal v is equal to 2d by t, 2d by t. So we know that we don't know the t if you have t1 and then t2. So if you take the average value, that means if you take both values to take a t, so t is equal to t1 plus t2. So t1, that means 0.9 plus t2 is equal to 1.1. So if we add these two values, t is equal to, it gives a 2 seconds. So if we find the t, so and then we substitute the values in this equations. So v is equal to 2d by t. So 2 into 680 meter divided by 2 seconds. So this 2 2 and then 2, this cancel that, this cancel this, 2 1 is to 2, 1 ones are 2. So 1 into 680, v is equal to 680 meter per seconds. So v is equal to 680 meter per seconds. And the next one, two observers are stationed in a two boards 4.5 kilometer apart. A sound signal sent by one. So if you send a signals from one board, so underwater reaches the other after 3 seconds. So a sound signal sent by one underwater reaches the other after 3 seconds. So what is the speed of sound in water? What is the speed of sound in water? So distance between two observers, we calculate the distance. So we give the distance between 4.5 kilometers, and then time t is equal to 3 seconds. So we know the speed of sound in water, that means v is equal to d by t. So v is equal to d by t. So v is equal to 4.5 divided by 3. So v is equal to 1 3 is 3, 1 3 is 3, and then 1 3 is 3, remainder 1, and then 15, that means 1.5 times, that means 1.5. So v is equal to 1.5 kilometers. V is equal to 1.5 kilometers per second. So if we convert the meters, so that's why v is equal to 1500 meter per seconds. So v is equal to 1500 meter per seconds. The next one, a strong sound signal is sent from a ship towards the bottom of the sea. A sound signal sent from the ship towards the bottom of the sea. It is received back after 1 second. So what is the depth of the sea given that the speed of sound in water 1450 meter per second? So we calculate the speed of sound, we calculate the depth of the sea. So they given a speed of sound, that means v is equal to 1450 meter per second, and then time is equal to 1 second. So we find the d. So v is equal to 1450 meter per second, and then t is equal to 1 second, and then d, we find the d. We find the d distance, that means the depth of the sea. So v is, we know the depth of the sea, v is equal to 2d by t. V is equal to 2d by t. So we find the d. So that's why we move from left side. So 2d is equal to v into t. So we know the v and then t. We substitute the values in this formula. So 2d is equal to 1450 into 1. So d is equal to 1450 divided by 2. So we divide the 1450 divided by 2. That means it gives a 1 2s are 2, 7 2s are 14, and then 2 2s are 4, and remainder 1, and then 1 plus 0 10, that means 1, remainder 1, and then 0, we multiply, we divide the 2, so 5 2s are 10. So its the value is d is equal to 725 meter. So d is equal to 725 meter. So the students should write the problems in your classwork notes. Don't skip the videos. So completely the problems, you should write the problems in your classwork notes. Thank you, students. Thanks for watching.